So this is 4.2 linear systems. And if you take a look at what we have here, what I have drawn is the coordinate plane. Have you heard of that before? I feel like last year you might have heard of that. And maybe to make it a little more clear, I'm going to draw an arrow here and call this X, and put an arrow here and call this Y. So this is the X-axis, and this is the Y-axis. Have you seen that before and this is familiar? We're all good with that? Okay, but I like to build in review, so I'll go through this a bit. Then on the right side here on the X-axis, it's just like the X-axis is basically a number line. So we're used to seeing that. It's just that now we've put something there vertically as well. Can I just ask for the cell phones to be put away while I'm teaching? Thank you. So this would be like 1, 2, 3, 4, 5. I'm just going to go up to, but we could choose. I could even go up by 2s if I wanted to. I could make it 2, 4, 6, 8, 10. It's just important that I keep it consistent on the other side. So this would be -1, -2, -3, -4, -5. So this is just like how to come up with a grid if I had you make it from scratch. Are we good with that? On the y-axis, it's the same thing. Y-axis always goes vertically, but above the x-axis would be 1, 2, 3, 4, 5. Going up would be positive, and 1, 2, 3, 4, 5 going down would be negative. So that's basically our coordinate plane with everything labeled on it. And then there's another part to it. We have quadrants. Have you heard of quadrants before? Yeah, okay, so there's 4 quadrants. Even the word quad, you know that quad means 4. So we're referring to these 1, 2, 3, 4 sections. And we actually go in a counterclockwise direction. Everybody know what I mean by that? Clockwise is if you take a look at the clock up there, look at the direction that it would go in. Counterclockwise is the other way. So I would call this quadrant 1. This would be quadrant 2. This would be quadrant 3. And this is quadrant 4. And are you all familiar with these Roman numerals for 1, 2, 3, and 4? So far this is all review. Good stuff. Okay, so then on here we could label something that we call ordered pairs. Have you heard of ordered pairs before? What is that? Anybody want to? Yeah.
It's like two numbers. So, for example, 0 and -3. And,
0 and -3. First one is X, and the next one is Y. Perfect. Thank you. Does everybody remember this, know this, recognize this? Okay, so let's start with this example, 0, -3. If I asked you to plot this on the grid, would everybody know where to put that? Because basically this is like a set of directions or instructions for where to go. We always start at this point. Anybody know what I call that green point I just marked in the middle there? It has a name. It starts with an O. Yeah. Excellent. This is called the origin. And that would be at the point 0, 0. So you can sort of see why that's the origin. That's like the starting point. That's where the two axes cross each other. So if we have 0 and -3, well, if the x value is 0, I don't move left or right. But if the y value is -3, I go down 1, 2, 3. So that point, the pink point, would be right there. Let's try one more. If I have, what should we do? Let's do -2 and 1. Which quadrant is that one going to be in? You can just call it out if you want. Quadrant 2. Everybody good with that? So from the origin, give me directions. Where do I go? Left or right? 2 to the left, and then if the y value is 1, we'd go up 1. So does everybody see that that's where that point would be? This is review and you all know this? Good stuff. I feel like maybe we're done with that. Are we done with that? Well, that was easy. Okay, maybe I'm wrong and this isn't going to Maybe we can do the whole thing today. Well, let's see how it goes, but so far we're off to a good start. So then let's take a look at the next little part here. We're going to look at linear equations, and the nice thing about this is, you know how yesterday we walked to the bog and we looked at patterns and we made up equations based on patterns that we saw going on? We've kind of already looked at linear equations, but I think as of yesterday you didn't quite know that this is what it's called. So I can give linear equations in different forms. The first one is called slope, intercept, form. And I'm going to show you what that means. We would have y equals, I'm going to do this in a different color, mx plus b. Have you seen this before? Some have, some haven't. Okay, no problem. We're going to review it anyways. Can somebody tell me what this m value means? What is that? Slope. Excellent. So this is called the slope. And the slope has a formula or something that we refer to it as. Anybody know what that is? What do we know about slope? Something over something. Do you? Excellent. It's rise over run. And I know, if you've never seen this before, you're thinking, what is that? Don't worry, we're going to do that. Rise is talking, it sounds like what it's talking about. Rise would be going up or down, or the y values. So this would be the y values over the run. If you think about it, you would run horizontally. So that would be your x values. So today is all about vocabulary, talking about the basics, setting things up so that we're ready for the next basically 3 chapters or so, because it's all kind of based on this stuff. So that's why I'd rather go slow and make sure you get the basics down so that we're prepared well for the next part that's coming up. Okay, this one's going to kind of look scary, but don't worry, trust me, we're going to go through what it means. But there's a formula to show this. y2 minus y1 over x2 minus x1. I'll say this, the formula makes it look like a big deal, but I'm going to show you using examples. It's actually so not a big deal. All this is referring to or looking at, like this is the formula for slope, is you're taking 2 points on your graph and you're just subtracting the y values and then dividing it by subtracting the x values. That's what this means, but the formula always makes it look complicated. So I'm going to introduce you to that, and then with examples, I think you'll find it's not too bad. Does anybody know what this b value represents? And or maybe you've never done this before, so I'll tell you if not. Yeah. Excellent. This is called the Y-intercept. I think the best way is for me to just show you with an actual example. So for now, just take a look at this, but know that I'm going to clear this up with some examples. Okay. So now that we've sort of talked about this, let's take a look at our first example. Let's say we have the points, well, let's draw a line with the points 0, 1. That's the symbol for width, the W with a line on top. You'll see me use it often so that you know what it is. So draw a line with the point 0, 1 and -3, -2. So here's our first task. We're going to draw our grid. We could do 1, 2, 3, 4, 5 on both sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's just to get a grid going. And then if we are going to draw these points, 0, 1, from the origin, where do I go? According to this. Do I move left or right? No, I just go up 1, right? Everybody good with that? Okay, let's take a look at the other point, -3, -2. From the origin, where should I go? Yep. Left 3 to -3 and down to -2. Everybody good with that? And then here's the important part, because a lot of people are tempted to just join these two dots. That is not the proper way to graph a line. What we would do to graph the line, it says draw a line, is we want to go through these points and extend it so that it keeps going and covers at least 3/4 of the graph, but if you can, just cover the whole graph. Does that make sense? So it's not just connecting the dots, it's actually extending it, putting arrows at the end to show if we stretch this thing out, it would actually keep going. Does that make sense so far? So using this example, I'm going to really quickly show you what I meant with the whole slope idea. So you know how I had that like y2 minus y1, blah, blah, blah. Let me show you what I mean by that. All that means is if I want the slope, remember how it was rise over run? In order to get from this blue point over to this green point, how many do I have to count up to get there? Do you know what I mean? If we look at this, how many would we count up? Up, 1, 2, 3. Everybody good with that? So basically, we wouldn't really draw on here, but I'm going to. I'd go up to here, right? So plus 3, so my slope or my y values at the top would be 3. And then how many do I have to go over this way to get to the green dot? It's going to be 3. Do we agree? 3, is it plus 3 or minus 3 if we're going to the right? Plus 3, so there's the work to figure out how we're getting this, but what's a better way for me to say, like, what's the slope? The slope's just 1. Does that make sense? Another way we could get that is I could go up 1, over 1, up 1, over 1, up 1, over 1. So it's showing us like the rise over run. So I know that that formula looked a little bit crazy or tricky, and I can actually show you how to get that. If we make this point here, let's say we make that point x2, y2, and I'm going to make the other point here, x1, y1. Then in this formula here, I would plug in the values. So what would be my y2 value from this point here? Well, we made, this was our green y2, x2. So what's my green y2 value? 1. Everybody good with that? And then according to the formula, I'm going to subtract. And what is my y value down here? Or it's this one. -2. Everybody good with that and see how I got that? You sure? Any questions? We're good with that? Okay, over what is my x2 value from the green point? 0 minus what is my x1 value from the blue point? -3. When we go to do the work for this, what do I do if I have minus a negative? I actually add them. So top and bottom, I'm adding them. So do you see how we're getting 3 over 3, which is 1, which is the same thing as that? So I could look at the graph to count up to find rise over run to get the slope, or plugging it into this pink formula is the same thing. Does that make sense? So it looks pretty complicated when you first see that formula, but do you see it's actually not so bad? So the key is labeling your points x1, y1, and x2, y2, and it won't matter which one is which, but I like to start, kind of like how we read a book, I like to start on the left side of the graph and go to the right. That's a nice way to do it, but it's not going to make a difference. You'll get the same end result or answer. Questions about anything before we move on? So far, so good? Okay, let's do another example, and then we might call it a day for this part. Let's say I want you to do the opposite, which is graphing y equals 2 over 3x minus 1. And we're going to do this together because I basically haven't shown you how to do this yet. So we do the same thing of 1, 2, 3, 4, 5 on both sides, and top 1, 2, 3, 4, 5, and bottom 1, 2, 3, 4, 5 to set up our grid. There's the first thing. Okay, you know how here we called this thing the Y-intercept? We talked about that. Does anybody know what the deal is with the Y-intercept? It's a very important point on the graph. There's something you have to know about it. Y-intercept is where our graph crosses the y-axis. The y-axis is the vertical one, right? We all know our horizontal and vertical. So if that's where it crosses, that means our x value is always equal to 0. Does that make sense? If we're crossing the y-axis, x has to be 0 because we haven't moved left or right. Do you see how this is sort of coming together? So if we have an equation like this in slope-intercept form, the nice thing about this is I just have to look at this part here, and that gives me a point to start with. So for step number 1 on my graph, I have a point from this. It would be 0, negative 1. So whatever value or number is written there, I know that the x-coordinate that goes with it is 0. So 0, negative 1. I feel like you're all very good at this. You know that it would be that point, right? So we're done with step number 1. Step number 2 is taking our slope here and taking the set of directions. So if the slope is rise over run, I'm going to do that. It's 2 over 3. So that would be the rise and that would be the run. So from my first point that I drew, if the rise is 2, where do I go? Like in what direction and by how many? From here. Yeah. Up 2. So I'd go 1, 2 up to there. And then if this is a 3 down here, oh gosh, the stressful thing about my job is keeping the color straight. So if this is run, then from that point, where do I go and how many in which direction? If it's positive 3, do I go left or right? To the right, so I'd go over 1, 2, 3 to the right, and that gives me my next point. Does that make sense so far? So technically speaking, we only need 2 points to graph out a line, but just to be safe, we could do another one. If I wanted to do another one here, I know from this, I'd just go up 2 again, so up 2 and over 1, 2, 3, and it'd be another point over here somewhere. And then again, to actually graph the line, oh boy, that's not very straight, but pretend it's perfect. We would go through and extend it and cover at least 3/4 of the graph, but you might as well just do the whole thing. So far, so good? This is where people usually start losing it, but you seem like you're not losing it. Am I right? You're feeling good? David? In the last one? Yep, it was positive. Because you go up and then over to the right. Right? So if we compare them, I'll show you both. Does that kind of make sense? They almost look like they're parallel. Yeah. Good? We all know what parallel means, right? Parallel, perpendicular, all these vocabulary words. Yes?
So the y-intercept, is that sometimes like coordinate like the other one?
Good question. The y-intercept, we love questions where we're given the y-intercept because it's nice and easy to work with because x will always be 0. So just the y-intercept, whatever value is there, know that it's always going to be matched up with 0, which is nice because that makes a nice first easy step for us to start with.
Okay, but that's not in every question.
That is in every question. Yep. If it's set up, if your equation is in slope-intercept form, like these ones, then yes, it definitely always is. So if y is isolated and it's by itself, and then you have mx plus b, then yes, it's always like that. It always has a 0 with it. Yeah, good? Alrighty, so we're doing numbers 4, 5, and 8. I'm going to get you to do just the odd letters for that.